As I mentioned earlier, logical separation of bounded context is orthogonal to the physical isolation. There are several degrees of such isolation you may employ, and each of them has its own pros and cons. The first one is keeping the bounded context in the same assemblies but in different namespaces, so basically just creating separate folders for them. Note that although with this type of isolation you keep the code of the bounded context physically close, you still need to maintain proper separation and don't allow them to infiltrate to each other. Boundaries should be preserved regardless of what type of isolation is chosen. Such degree of separation also means you share the same database instance, but again, entities in different bounded contexts should be stored in different tables. If you use SQL Server, it's a good idea to define separate database schemas for each bounded context to make this distinction more apparent. The second type of isolation is extracting the bounded contexts into separate assemblies under the same solution. Here, for example, you can see two solution folders for bounded contexts and a separate project for the shared kernel. Note that each folder contains its own UI and logic assemblies that regard to a certain bounded context. The third type of isolation is separate deployment. While the first two types imply the bounded context work in a single physical process, this type of isolation means you deploy and maintain them as separate applications. The source code is stored separately, and there are separate database instances for each of the bounded contexts. This type of isolation is often referred to as microservices. The topic of microservices is out of scope for this course. If you want to learn more about it, I recommend you to read this article. It's important to understand the benefits and drawbacks that each of the isolation types entails. The benefit here is that the greater the physical isolation is, the easier it is to maintain proper boundaries between bounded contexts. You are less likely to violate them if the bounded contexts reside in separate assemblies or even in separate solutions. At the same time, the more you isolate your bounded contexts, the more maintenance overhead this isolation introduces. It's harder to deal with separate assemblies in your codebase than it is with only one, and it's even more difficult to handle separate deployment of them in case the third type of isolation is chosen. The guideline here is that you should be pragmatic about the degree of isolation you choose and introduce greater physical separation only when the benefits of it is justified. If your bounded contexts are small enough, it's just fine to start with the first type and move forward only when you feel the code gets bigger and it becomes harder to keep it clean without introducing additional physical boundaries. In our application, we will adhere to the first type because we don't have large amounts of code in our bounded contexts. This is how it looks like in practice. You can see there is a separate folder for the snack machine context with all classes related to it. The ATMs folder is empty because we don't have any code for the new bounded context yet, and the shared kernel contains a single money value object. Note that we also have a folder for common base classes and the other one for utilities. They are shared by all bounded contexts. We will talk about sharing code between bounded contexts later in this course. Also note that we have the same kind of separation in the UI project, two separate folders for each of the bounded contexts. The way entities in different bounded contexts communicate with each other depends on two elements, the type of isolation chosen and the relationship between them. Let's take the first two isolation types, the types that imply you host bounded contexts in a single process. In this case, the communication pattern depends on whether or not there is an anti-corruption layer between the bounded contexts. If there is none, entities in these bounded contexts can just call other entities' methods directly. Also, the communication can be performed via domain events, which we'll discuss in the next module. In case there is an anti-corruption layer, the things get more complicated. An anti-corruption layer usually means that developers working on one bounded context don't want to interfere with the concepts from another bounded context. It's often the case if that other bounded context has become a big ball of mud, or in other words, a mess. Another use case for introducing such a layer is working on a legacy project where you want to keep the new code isolated from the concepts in the existing codebase. Regardless of the actual reason, the presence of an anti-corruption layer means that you cannot just allow entities in your model call entities from the other bounded context. You need to introduce a proxy between the two models which would handle all translations for them. So whenever you need to perform a call, your model calls the proxy instead and gets a response which is formed in a way that is familiar to it. In case the third type of isolation is chosen, meaning that two bounded contexts are hosted in separate processes, the communication goes through the network. For a direct call, it is usually an HTTP call using REST or SOAP protocol. For an event, some sort of a message queue is used. In this situation, you don't have to create an anti-corruption layer between the two bounded contexts, because this messaging mechanism essentially acts as such. An important topic which is often gets misunderstood is code reuse between bounded contexts. It might turn out that there is some code which is common for two bounded contexts and which can be factored out and reused in both of them. The first temptation in such situation is to perform the extraction in order to comply with the don't repeat yourself principle. On the other hand, we have a guideline which says there should be strict boundaries between bounded contexts, and developers should not allow concepts from one context to infiltrate to another. So how to deal with this conflict? To answer this question, we need to define different types of code which can be a potential subject for reuse. The first type is code that carries business logic. Such code should never be reused unless it has the exact same meaning for all bounded contexts involved. For example, you might have two bounded contexts, sales and support, which both contain a product entity. It may even be that these entities have some behavior in common. In this case, you still need to create separate entities for them in both bounded contexts and store them in distinct database tables. The reason here is that despite the fact these entities have some commonalities, they still represent different concepts. The sales perspective on what a product is not the same as the support perspective on it, even if that is the same physical product. You shouldn't try to merge the two concepts into a single entity. At the same time, two domain classes might have the same meaning for different models. For example, both snack machine and ATM bounded contexts have identical perspective on the money value object. It represents the same concept for both of them. If this is the case, you do need to reuse it by extracting this class into a shared kernel like we did previously. It's a good idea to treat that kernel the same way you treat a bounded context and strictly maintain its boundaries. The second type of code is domain-based classes, such as entity, value object, repository, and so on. They don't contain any business logic themselves, but are still used by the actual domain classes in your bounded contexts. The answer to the question whether or not to reuse such code depends on the team configuration in your project. If you have the same team working on two bounded contexts, then it's a good idea to reuse domain-based classes. On the contrary, if there are separate teams working on those models, they are better off to have their own implementations of those base classes, even if those implementations are identical. The reasoning behind this guideline is that despite the fact the base classes don't contain any business logic, they still are an additional point of coupling between the models. It is fine to have that point if you have a full control over the bounded contexts that use these base classes. Otherwise, it becomes a burden to maintain consistency in changes that are made by different teams. So, one set of base classes per each team, regardless of how many bounded contexts they are used in. In our application, we use the base classes, because we are the only team working on this project. The third type of code is utility code that doesn't contain any domain logic, but rather represents some useful helper methods. The guideline here is roughly the same as with the domain-based classes. If a utility is small, such as Session Factory in our application, just duplicate it so that each team has its own set of helper methods. At the same time, if such code gets bigger and you see it can potentially provide a lot of value to all teams in your company, create an internal open source project out of it. You can extract it to a separate project and make it publicly available to all teams in your company. But that should be something really useful, not just a set of random auxiliary classes. Overall, try to avoid reusing code between bounded contexts as much as possible, especially reusing the code from the domain layer. Extract a domain class to a shared kernel only when all bounded contexts involved have the same perspective on what it represents.